Hey everyone, this is Forrest Burt from CIQ, and I'm here today with a Fuzzball workflow demo. So in this workflow, we're going to be looking at running the LAMMPS molecular dynamics suite across 4 nodes at once using MPI. So first off, I'll go ahead and show you exactly what our workflow definition for this looks like so that we can know exactly what this workflow is going to run and how we define that. The versions field up here at the top defines the version of our DSL that this workflow definition is written in. The volumes field here defines the data volumes that are going to be set up for this workflow so it can run correctly. We're setting up one volume called V1. It's an ephemeral type volume, meaning that it'll only exist for the lifetime of this workflow. And we're going to ingress a file from this URL into this volume and place it at the top level of that volume with this name. We then have the jobs field, which is the section that defines the computational jobs that this workflow should actually run. In the case of this workflow, we only have one computational job, and that's run LAMMPS. The next field here, MPI, defines how we want MPI to be wired up for this workflow job. And in this case, we're defining that we want 4 compute nodes wired up with an OpenMPI implementation of our MPI wrapper. And I'll explain here in just a moment how we determine the resources that we want on each one of those nodes. We're going to be running out of this container image here, pulled from this URL. So you can see this is a LAMMPS container that we're pulling down from NVIDIA's NGC. We're going to be running this command inside that container. So this essentially represents what this computational job is meant to do. You can see that we're basically just running LAMMPS with an input file at this location. And I'll explain where /data comes from here in a moment as well. You can see we have a current working directory, meaning this command is going to be run inside of this directory here. We also have a policy set for this job that essentially means that if it starts and it fails to complete within 10 hours, it'll automatically time out and stop. We then have the resource requirements for each one of the nodes that we're requesting for this workflow. So in this case, we're looking for 8 cores pulled from the minimal number of NUMA nodes on a given compute node that those cores are coming from, and then 30 GB of RAM also available on that compute node. So because we requested 4 nodes here, we're going to be looking for 4 separate nodes, each one with these resources available on it, for a grand total of 32 cores and 120 GB of memory available to this entire workflow job to be able to run in MPI over. We then also have the data volume here that I discussed earlier being mounted to this workflow job. You can see that we have the name of the volume that we're mounting, which is V1, and matches to that right there. And then the location that we want to make this volume available inside the container at. So in this case, we're going to be mounting this volume to the container at /data. And so you can see that's why up here, when we specify the input file location, we do /data / the name of the file that we ingressed here. And as I mentioned, this essentially places it at the top level directory of this volume. So you can see that it's essentially just right inside that volume at the location we attach it at. So we'll go ahead and start this workflow. Fuzzball workflow start, and then we'll provide a name for it. So we'll do cq.co lamps mpi demo /1. We'll go ahead and provide the path to the workflow demo that we're going to be, or to the workflow definition file that we're going to be using for this. It's in the same directory, so I basically just have to specify the name. You'll see we get a message saying that this workflow has started along with the name of it. I'll go ahead and pull up Fuzzball workflow status for this workflow, and I'll add the watch flag so we can watch it live and have it print continuously the status, basically. Go ahead and paste that in there. And we can see that this workflow has started. The volume has already been set up. The image is already finished downloading. It's essentially cached from other workflows that have been run. And then this file ingress that we defined here is currently happening. And then once we see this finish, we'll see the nodes for this job that we have start to be provisioned. So that'll basically just look like this finishing and this staying as pending. And this will probably fast forward a little bit while we wait the few minutes for this or for those nodes to be provisioned. This workflow is being run on a public cloud provider on a Fuzzball cluster that's been stood up there. And so when we request these 4 compute nodes matching these requirements right here, it's essentially going to take a definition that we've set up within Fuzzball of a certain type of compute node, or the definitions that we've set up, find which one best matches this, and then spin up 4 of those and then start this workflow job on them with our MPI wrapper. So we'll give this a few minutes to run. Like I said, this will probably speed up for a second, and then we'll return once these nodes have been provisioned and this job is started. So now we can see that this workflow is started, and the job status, well, the workflow job, run LAMMPS has started. So we can see that that job, and it finished there really quickly, but you can see that job changed status from pending to started. That means that those 4 nodes completed provisioning, and the command that we specified up here started running on those nodes. And so we should be able to now go and actually view the logs from that run of LAMMPS. So we'll do fuzzball workflow log, and then we'll specify the name of the workflow. And we should get some output here showing that we were running over 32 cores at once. That'll indicate that this workflow job ran successfully, and thus the workflow finished successfully. So you can see that we indeed have some LAMMPS output here. Because we're running this in CPU-only mode, you'll see that we get some CUDA errors, but as mentioned, those we're just running in CPU-only mode, so we expect that. You can see down here that we have 32 MPI tasks, which is the 32 cores we were expecting. We get a measure of the performance coming out of this. And yeah, we can see that based on this, the workflow ran successfully, and we were able to run LAMMPS as a fuzzball workflow. So thank you for joining this demo, and please feel free to take a look at our other materials surrounding fuzzball or the other services and products that CIQ provides. Thank you very much. Have a great day.